Certainly very stimulating discussions today, and great to see all the inspiring technologies that have been put forward. It really restores my faith in that we've got lots of bright people looking at really important solutions that we have to all develop. I am talking about innovations in plastics that are leading perhaps to a more resilient and more effective circular economy. I'm just trying to get my slides to index. Okay, just a little bit about Nextech. I left RMIT many years ago to go into the area of recycling because all my work was suggesting that we were going to have a big issue with the end destination of plastics. So we could see a long time ago, just like many other things, science gives us the tools to look forward, and you know, I felt that we needed to act in this area. And in the case of recycling of plastics, we barely use any advanced technologies to replace virgin plastics. But time has moved on. It's now a big topic of conversation at both the community level and at intergovernmental level. And in Australia, we're going to change what we're doing. And as of July this year, the government has banned the exports of mixed plastics bales, typically to Asia. Now, lots of people think when they put their packaging into a yellow bin for recycling, that it actually gets recycled. Well, in the past, it was collected and that was counted as recycling. And of course, the two are not the same. And by the middle of next year, we will also only be able to export materials that have been not just collected, but also sorted and upgraded into single materials. The other thing that's worth mentioning is in Australia, we barely have a plastics industry that makes plastics here locally. We import something like something like 2 million tons of plastics. We only manufacture about 1 million tons. So out of a total consumption of about 3 million tons. And this point is important because later on, when we look at innovations that might address the issue of what do we do with end-of-life plastics, we have to remember we only have 2 operating refineries left in Australia that can actually crack crude oils into other products. And the other comment I'll make is right now, out of the 1 million tons of packaging that we currently make and use in Australia, we recycle 125,000 tons of that 1 million tons of packaging. There's 820,000 tons going to landfill every year. And if I was going to set up an activity to recycle plastics, it's a bit like mining, well, we really should be looking at what we're sending to landfill as opposed to what we're putting into the yellow bin. But come back to that a little bit later. There are lots of statistics around this now. I won't spend too much time, but we actually lose a lot of the value that we currently landfill. We lose something of the order of 250 million a year because of what we do. And there's roughly half a million tons of greenhouse gas savings that we also miss out on because we're not doing something effective about those materials. The approach that everybody's looking at now to try and address what to do with plastics is to create a circular economy. And this literally means that we need to take what we currently classify as waste and turn it into new materials. And ideally, a circular economy takes those waste materials and puts it back into products. And ideally, they should be put back into the same sorts of products where they came from to really make this circular and to make sure we have markets that are big enough to actually take these recycled materials. Most plastic products are designed to be used once and thrown away. And that's our linear society. We've been going this way for many years, probably 60 years. And of course, we now need to change our thinking. And part of the direction here is to actually design for recycling. And we typically make plastics and packaging many colors. And under a strategy where we might want to unify these things, we can actually make things really simple for sorting And so, for example, we could make food grade packaging clear, we could make non-food packaging either white or pastel colors, and for packaging that contains poisonous materials, we could make them black. And there are some good technical reasons why this might be the case, but I won't elaborate just yet. In Australia, 25% of all the packaging we make is poorly recyclable. In other words, we design packaging that can't be easily recycled. And this means it really gets discarded by the recycling businesses because they can't actually add value to it. The other big block in the circular economy is much of the packaging that we use is for food contact. And to recycle back into food contact applications is actually technically possible, but it is difficult. And in this case, you actually need to be able to sort food packaging from non-food packaging. And that's a challenge which I'll talk a little bit about. There's another important limitation on the circular economy, and that's how efficient are our systems in collecting, sorting, and recycling. And there's a simple little equation which says that we can probably recover easily 60% of all the materials we put onto the market. And that actually means that even in a circular economy, we probably aren't going to complete the circle with these materials as a resource that can go on and on. But that's obvious, that's often the case. So the sort of things that we need to do to create a circular economy relate to, I think, three things. One is the need to create a much better infrastructure on collecting material. Right now, we do collect, but we actually still send a lot to landfill, and we don't sort out the materials from the waste stream. And as I mentioned earlier, we really should be focusing on what we send to a landfill, because if we resorted that fraction, we'd get far more than we currently collect. But that's again, a big issue about the way we handle and, in fact, the way we generate waste. The other big opportunity here to create a circular economy is to put recycled content back into packaging. It sounds obvious if you want a circular economy. And we need to start with design. And much of the materials that we import into Australia are brought in from typically China and other countries. And so the products there are less well regulated by Australia. And so we can't actually always guarantee recycled content. And indeed, there are possibly good reasons for that. But I want to come on to the innovations, and I'll spend a bit more time on this now. The main challenges I want to talk about are the sorting of food grade materials from non-food, and also looking at the recovery of plastics from waste before landfill. Can this be done? Indeed, it can. And then looking at creating high performance materials in closed loops in existing and also new applications. I've got a list on this slide of all the things that we don't have, and top of my list is the absence of a shared vision in Australia about how we go about these problems. And the big thing here is that we don't really have a buy-in from the producers of the products. They don't actually see that we have a big problem, and essentially are only now starting to move in the right directions, but they're not fully activated to actually shift in a big way that the problem we have with the way we actually retail materials, the way we create materials that are not high value, and also the fact that we don't have a unified approach. And this goes from the chemical producers all the way to the retailers and the brands and the converters. This is changing, but it needs to change fairly quickly if we're going to make a big impact. There are lots of comments about chemical recycling, and I will mention chemical recycling in a little while. But just a little bit about brand owners and what they probably need to do. When we actually create a recycled material, we don't have the control we have in making petrochemical products. And so recycled materials should be different, and we should expect them to be different. And I've got here on the image pairs of packaging. One bottle has recycled content, and as a result, it has a slight color variation. Now, if you go to a brand owner and ask them what they'd like to do, they'd like to see every bottle exactly the same. Well, if we truly are going to be circular, maybe we need to think about how we change our expectations, but also perhaps, do we always need the same type of pigmentation that we're currently putting in? Because this limits what we do later on. Most products, as I mentioned earlier, are designed for functionality and for appeal to the consumer, but they don't necessarily appeal to the recycler. Things like the adhesives they use on labels, the inks they use, the colors of the caps, all can have a big impact on the recyclability of these materials. And from a technical point of view, sometimes they can be really problematic, and life would be a lot easier if we could change all that. Here's an example of products that we were working with a company with different amounts of recycled content. We could go up to very high levels of recycled content and then put a sleeve onto the outside of the bottle so that the brand owner could actually make the same looking product with a very slight difference in appearance. And this is a very simple way of actually changing the amount of recycled material they could use and still put the material onto the shelf, although there are even better solutions for that. So companies are now looking at how do they simplify their designs. No labels, no glues, perhaps, and unpigmented caps. And there are lots of examples of this happening, but there are lots of examples of this not happening. You know, here are some examples of polypropylene that are produced every day, and all of these are highly pigmented and clearly never been designed to be recycled because of the pigmentation levels. There's no thought about where this will end up later on. But you may not even know that many products are on the market and contain recycled content. So for example, in Australia, some companies use milk bottles to produce milk bottles once again. And these materials are put through a technical process where they are completely sorted, cleaned, decontaminated to make sure they meet the food grade requirements. And this is completely possible. In the United Kingdom, every bottle is made with at least 30% recycled content. In Australia, it's much more variable. A project we've started is one that recycles polypropylene, because this has been missing from the range of plastics that could be put back into food grade. And we've got a program with about 36 companies that are working on this particular goal. And we have the whole supply chain involved, from the brand owners to the converters to the technology providers. And we're demonstrating that this can actually happen. I've got a brief video about sorting. And I mentioned sorting because this is actually quite important if we want to have the concept of how do we segregate materials based not just on polymer type, but also end use. So in this case, we're using fluorescent markers on a label, and those fluorescent markers are made visible by ultraviolet light. And once the ultraviolet light fluoresces in the visible spectrum, the items are picked out and we can deselect those particular items. So we now have a basis for separating food from non-food materials. And we can apply this to a whole range of plastics. And this now means we've got a platform for separation. And of course, if we're really serious, we would be doing this and applying it to more applications. So just to say a few words about mechanical recycling, because this is something that can happen in most countries. It's being done by taking packaging, putting it through a series of mechanical steps that include sorting by near-infrared to sort the polymer type, washing, grinding down to small sizes of flake, and then re-extruding it, into granules and then subjecting it to decontamination steps. And we can go a long way towards that. And this is what these plants look like. We have them in Australia. We have them right around the world. Wherever plastics are collected, we can put a recycling operation in. My point here is we don't need to do anything overly exotic, but they are quite reliable technical operations. But let me talk a bit about chemical recycling, because chemical recycling is being seen as the savior for plastics packaging and as a technique for recovering the carbon content of these polymers and putting them back into recycling. Well, it could well come. Lots of work is happening globally, but in the Australian context, we only have 2 refineries that are very busy making fuels for cars, for planes, for many other applications for liquid hydrocarbons. And it's fairly unlikely that we're actually going to see large-scale chemical recycling operations here. Now, I hope that we do get some things happening, but it's unlikely that this will create the circle for making new polymers, because simply we don't make many polymers here anymore. We make polyethylenes and polypropylene, and that's it. We've stopped making many of the others. I also get asked lots of questions about making things degradable and compostable. And indeed, we've worked pretty hard at doing this and lots of investigations. And here's a tray made from polyhydroxyalkanoates. And these materials are eminently digestible. They're basically made from sugars. And these trays took something like a year to decompose in a conventional ambient compost. So it shows that we really can't rely on loading up the biosphere with these materials and waiting for these materials to decompose. And of course, we don't end up with any material other than CO2 and water. So perhaps we need to switch back to our way of going to a circular economy and get some value out of those materials. In my sort of nearly last slide, my feeling is that we have a big problem with what we do with plastics, especially after the first cycle. And indeed, we're trying, I think, globally to use less plastics, to ban single-use materials, try to stop them from getting into oceans. And of course, we need to do all of this on a big scale. This is really where we're missing out on dealing with the problem. I was very heartened by something I saw in a magazine just recently, which is the bottom of my slide, where Visi Glass have said they've just increased the recycled content in their glass bottles from 33 to 43% in just 10 months. Well, in Australia, we recycle 5% of our plastics. And it just seems like we're really not serious about the collection and the recycling. Although right now, there are now quite a lot of new investments happening in nearly every state because the federal government has encouraged companies to reinvest. That, I think, is very encouraging. And I'm looking forward to something happening to shift the dial forward. And here's my last slide about inspiration and innovation. We're able to fly to Mars. We're able to send a small rover flying around. And I think that, to me, innovation is all about imagination, as one of our earlier speakers mentioned. And so if we can imagine it, then we can do it. And for some of our big problems, indeed, we must do it. So that is my last slide. Thank you.
Thank you very much, Edward, for a wonderful talk and very connected to environmental sustainability and circular economy. I think we have time for one question. Running a bit late, but I think one more question. And of course, people can ask you more questions as you're part of the panel discussion that is coming up soon.
Can I ask a question too?
Sure.
Hi, Edward. It was an excellent presentation. I know circular economy is a big buzzword today in Australia. I don't know how much of funding you're getting. But at the end of the day, I think you know how agriculture industry, they use 10% of the total plastic consumption, especially in the mulch market, and most of them are non-degradable. So the legislations are trying to ban their use in agriculture applications. So there would be no recycling of those anyway in the future. Do you think the biodegradable polymer would ultimately replace some of the industries like in agriculture, mulch or food market to be using, and we will not need to be recycling them?
Well, I think that's a great example of where biodegradable films may have a good niche where they are truly recyclable. The problem is the rate of biodegradation is actually quite slow. And if you don't have the right environment, they may not decompose as you may wish. But look, I know people are working on this in mulching because it is a big problem. But that said, I've actually seen agricultural films being recycled quite regularly. It's we've designed plants that can do this. There are plants running in lots of countries, and it's being done in Australia as well. It's more problematic. It's a bit more work. And, you know, I keep getting this feeling that we like biodegradable materials because we actually could just leave it there and let nature's bacteria and other enzymes do the job. We're often quite lazy about our attitudes, and this then spreads to other areas as well, you know, as opposed to taking responsibility. And it might be good in some areas like agriculture, but there are so many areas where we are so negligent about the way we treat our environment, which actually provides all of the value that we all benefit from. So it's horses for courses. Certainly in cities, we can't apply that, but in agriculture we can. And, you know, with CSIRO's work in this area, it'd be great if they actually focused on some of the circularity areas as well as biodegradation, because I think, you know, we've clearly got a global problem, and we need, you know, a lot of good science. We need applied science, like some of the innovations we've been hearing from. I'm absolutely fascinated by what I've heard, but we actually have neglected the issue with plastics, and I think it's the producer responsibility now which will shift things. And in fact, the innovations we've mentioned are facilitating the addressing of the problem. The big shifts will come from governments when we have taxes on recycled content or packaging that doesn't have recycled content, and when we actually mandate recycling, and when we ban products that we know are causing all sorts of damage because they're low value and they leak into the environment. So it's the government, the infrastructure, the attitude of companies that make these products that will actually shift and solve the problem. The technologies will just facilitate a better way of handling some of the other issues.
Yeah, thanks. I think there are a lot of attempts. I think Monash CSR is definitely involved. I don't know to what extent, but I have been involved in one of the projects with the Monash University where we're trying to recycle and making to an industrial product, you know, by doing some polyurethane chemistry. Anyway, thanks, and an excellent talk.
Thank you.
Thank you very much, Edward and Raju, for asking the question. It was a wonderful discussion, and